Welcome to Back to School Night. My name is Tim Erickson, and I am very, very pleased to be your children's statistics teacher this fall. First, we're going to begin with excuses and an apology. I'm really sorry I'm not here in person, but my esteemed colleague Anna Lee is going to run this session and answer questions that you might have. But you can also talk to me about this at any time. I'll give you contact information at the end. So first of all, what is statistics? On the very first day of class, I asked this question of the students, of your children, and their answers were so good, I'm going to just show you what they said, because we put them up on the screen. We're going to talk about percentages, about ratio, about patterns. That's very, very important. We're going to be compiling information over time, and to prove that this is really from a student, compiling information through like surveys. They're going to deal with generalizations, with graphs and tables, with analyzing data and interpreting data. And that's a pretty good list. Now, if you've taken statistics before, you might be familiar with things like hairy formulas. That's not part of this course, but rather we're going to be looking more deeply at what statistics is all about. In fact, as I told your children, we might have called this course epistemology, which brings up an important question. What is epistemology? Now, if you look it up in a dictionary, it says this. It's the theory of knowledge, especially with regard to its methods, validity, and scope. Epistemology is the investigation of what distinguishes justified belief from opinion. Now, for me, there's really only one response to this definition. Huh? Okay, so let me put it a different way. Epistemology is the study of how we know what we know. And that's really important right now in our society, because if we ever want to go from opinion to justified belief, in a lot of situations, we need statistics. Let's see what's next. Ah, yes. I need to say something about where this course fits in at Lick-Wilmerding. Here's our course scheme, and statistics is over here, kind of off to the side. Now, at the very top of our course scheme is up here at Honors Calculus. And that's true of lots of schools. It's as if calculus occupies some sacred place. It's as if it's at the top of the educational pyramid. Let me tell you. Calculus is gorgeous. I love calculus. But you want something useful that you're going to use in your everyday life? Give me statistics anytime. I wish everybody took statistics, and I'm really glad that your kids are. Okay, enough of the rant. Let's move on. What's in this course? We're going to have a massive use of computers, and one of the programs we're going to use most is Fathom. And let's show you something about that. So let me show you the kind of thing we're doing with Fathom. Here we have a set of 336 people from the U.S. Census from the San Francisco Bay Area in 2000. There's a table here with all kinds of information about them. Let's go ahead and make a graph and see what sorts of patterns we can see. I'm going to drag sex to the graph. I'm going to put it on the vertical axis here. And here's a bar chart that shows that in this sample there were slightly more males than females. Now, in this data set, we have all sorts of information about these people, including, for example, their total personal income. This is really interesting data, especially for us adults. I'm going to put it on the horizontal axis. And what do you think is going to happen? Who do you think earns more, the men or the women? Let's find out. I'm going to put it here on the horizontal axis, and I get this graph, and it's not obvious who earns more. But if I change this dot plot to what's called a box plot, which is something your children have just recently learned about, I can see something about the distribution. I'm going to move these points out so I can see the box a little better. And one of the things you can see here, the median income right here in the middle for the men was about $40,000 a year. For the women was about $15,000 a year. So the 50 percentile of the men was $25,000 higher than that for the women. Just kind of appalling. But let's see what kind of information we get about these people. Let's double click this woman here, the woman who's making a lot of money, and see who she is. Well, I can look in this box here, and I see that she's a 47-year-old white female who's never been married, never married. She's not Hispanic. She has a college degree, and she's an insurance agent or broker, and in 2000 she made 156.5. And does she carpool? She does not. She drives alone. So you get an idea of how rich the data are, kind of how spooky they can be, but importantly, how we can learn about our own society and how we can test our own preconceptions about what's happening. Students love this kind of data. We have all sorts of different data sources, including health data, other demographic data, data from past Lick students, and we'll be collecting a lot of data of our own, of course, over the course of the year. What we've seen so far is called descriptive statistics. That includes being quantitative about an effect. And the one we saw, the question is, how much more do the men earn than the women? And we came up with an answer, about $25,000 in the median. We go beyond that, however. In the second semester, we look at inferential statistics. The essential question there is it plausible that the difference that we saw was just due to chance? The answer is no. But in order to answer that question, we also have to study probability. So that's another thing that we're going to look at. But throughout the entire course, part of what we're going to be looking at is thinking critically. And I'm going to conclude here with another example from Fathom. Back in Fathom, we have another sample, this time 5,000 people from all over the United States. I'm just going to take age and drop it on an axis so you can see the distribution of ages. Look at that, there's one dot for every person in our sample of 5,000. The thing I'm going to ask you about is, look at the overall shape of this distribution. I'm going to change it because there's so many dots, from a dot plot to a histogram, so you can see what the distribution looks like. If I asked you or the students, what can you tell me about the shape of this distribution? One of the things you would probably say is it's relatively flat here, goes down over here. That is, there are fewer old people than there are young people. So what I'd like you to do is to take a moment, talk to somebody near you, and see if you can decide why this phenomenon takes place. Why are there fewer old people than young people, as seen in the graph? Now that you're done discussing that, we could close with two big goals for the course. What I really want for your children. One of them is to learn to make effective and valid arguments using data. And the other is to become a critical consumer of data. If we do those two things in the course of a year, we will have done a good job. And I'm looking forward to working with your students to accomplish both of those goals. Finally, here's the contact information. Don't hesitate to contact me.